Mesomeric effect. Before study about mesomeric effect, we will learn something basic concept which is required to know mesomeric effect. We need to know about conjugation system, which is very much important, which is required for learning the mesomeric effect. What is conjugation system? Conjugation system. Uh, a given atoms or molecule is said to be in conjugation with the unsaturated system if we directly link to one of the atoms if directly linked to one of the atoms through a multiple bond through a single bonds, means this is multiple bonds linked to a multiple bonds, yeah, positive charge. This is a multiple bond, this is a multiple bonds. It is directly linked through a single bonds to a multiple bonds group, या positive charge, या lone pair, या free radicals, या multiple bonds. This is whole can be considered a multiple bond with a negative charge. I have written the condition. It is directly linked to a one of the atoms of multiple bond through a single bonds. Through a single bond, it has a pi bond, a positive charge, negative charge, odd electrons, a lone pair. Means here this is group with, means any compounds, if one pi bonds is there and one lone pair and a positive charge, free radicals, anion, anything will be there which is in conjugations in alternate position, then the system will be said as conjugation systems. So this type of structure is conjugation system. Here is alternate positions, pi bonds alternate positions, but in a structure at least one pi bond must be there. Here it is in the conjugations. Here is alternate positions, plus charge and double bonds and lone pair, nitrogen's lone pair, it is in alternate positions, double bonds, free radicals, double bond, anion, they are all in conjugations. So according to the definition, if you will apply these 2 points, first point is a given atoms and molecules, means any given atoms, yeah, any given atoms, this is side, any given atoms, any given atoms, indicator is said to be in conjugation. When is said to be conjugation? When it is directly linked to an atoms of a multiple bond through a single bonds, means this is linked to a multiple bonds atoms or group of atoms through a single bonds. Through a single bonds, this atom is linked with a single bonds to a multiple bonds group of atoms. Through a single bonds, this is linked with the double bonds, but this groups has a pi bonds. This is a pi bonds, yeah, positive charge, yeah, lone pair, yeah, free radicals, yeah, anion, negative charge. Anything will be there, the group of atoms is said to be in conjugations. So this type of system is said to be conjugation, which is required to know the mesomeric effect. Now we will learn about the mesomeric effect. About the mesomeric effect, let's take a butadiene one example. By this example, we will learn about the mesomeric effect. This is a conjugation system. This is in a double bonds in alternate positions. This is in a conjugation system. This is the same example like this. This is the same example like this. This is in a conjugation system. In such compound which has a conjugation, pi electrons are decoalized. Means if conjugation is there, then pi electrons will decoalize. Means there is maybe shifting of these pi bonds like this. Now compounds will be now one mistake is there. Says true. Now compound will be like this, and in such compounds which has a conjugation, pi electrons are decoalized. Here this pi electrons are decoalizing, means they are moving, and polarity is developed. Here negative charge, positive charge come, and polarity is developed. Pi electrons are decoalized and polarity is developed in a molecule. Here polarity is developed in a molecule. Same being is also happen when atoms or group of atoms is lone pair electron is situated in a conjugation with a double bond. Means same things can be happen if this type of conjugation is there. Yeah, such type of conjugation is there. CS2C lone pair. This type of atoms. Here this will move like this, and here negative charge will come, here positive charge come, and by this it will move like this. Now this is CS2 negative C here the polarity is produced. Same thing means if any compounds have a conjugation, then by the decolization of pi bonds electrons there is a polarity is produced in the molecules. Polarity is produced in the molecule develop. Then in this way we can define the mesomeric external definition of mesomeric effect. Mesomeric effect refer to the permanent polarity produced in a conjugated molecule as a result of decolization of pi electrons. Means by decolization of the pi electrons polarity produced in the molecules, it is a permanent effect. So as a decolization of pi electrons polarity is produced in the molecules, it is referred as a mesomeric effect. This is also known as conjugation effect because it is happening in the conjugated molecules. So this type of effect can be called as a mesomeric. This is the definition we need to remember. Mesomeric effect refers to the permanent polarity produced in the conjugated molecules. Means molecule must be conjugated, then can only pi electrons will be decolized and polarity can be produced. So this type of effects can also be called as the conjugated effect. There are lots of definitions I have already written. Mesomeric effect is defined as a permanent effect of pi electrons shifting from multiple bond to atoms, or from multiple bond to a single bonds, or from lone pair to a single bonds. The mesomeric effect is a permanent effect and operates in a compounds containing at least one double bonds and another double bonds, a lone pair separated by single bonds. Means this type of compounds lone pair is there, then this lone pair will shift like here, pi bond will shift like this, and this lone pair will shift like this. Then here a plus charge will be generated, a negative charge will be generated. Now this is shown. So this in this way the polarity is produced in the molecules. In the conjugated system is there and polarity is produced in the molecule. Here is a lone pair and pi bonds are in conjugation and are in the alternate positions. So this effect mainly operates in a conjugated system of double bonds. So this effect is also known as conjugated effect and mesomeric effect. In these molecules, here is a pi bonds and conjugation. This pi bond shift like this, here minus charge is generated. This pi bond shift like this position, here plus charge will be generated. Now here minus charge plus charge are shown, they are in the end of this, and the polarity is produced. This type of effect is called mesomeric effect. Mesomeric effect is generated in the conjugated system. These all are happening according to the resonance, but this effect is called mesomeric effect. Understanding the detailed mechanism of mesomeric effect. Mesomeric effect means in a carbonyl groups, oxygen has a more electronegativity than the carbon, so it will attract the electrons of pi bonds and it will acquire a negative charge, a plus charge. Now this way polarity is produced in the molecules. So 1 and 2 structures are given, but 3 structure is more preferable structures, and the movement of the electrons will be shown like this arrow. Here now I will read one by one statement. In a carbonyl groups, the oxygen atom is more electronegative than the carbon atoms. The carbonyl groups I have shown the oxygen is more electronegative than the carbon atoms. The pi electrons of the double bonds get displaced toward the oxygen atom. Because oxygen is a more electronegativity, that's why the pi bonds electron shifts towards the oxygen atoms. Shifting electrons is shown by the curve arrow. If the shifting is shown by this curve arrow, this will give ionic structures. This will give this is the ionic structure we are getting. The actual structure seems to be lying between the structure 1 and 2, which is the best representation as the structure 3, in which 5 electrons are drawn preferentially towards the oxygen atom. Means 3 structure is more prominent because this is the middle position, but pi electrons are shifted towards the oxygen atom. So it is a more preferable. For understanding, for clear view what is happening, it is shown. They are slightly shifted in the right side, so it is shown that oxygen are negative, more electronegative, so it is trying to pull the electrons towards itself. Now if the carbonyl group is conjugated with the double bonds, if the carbonyl group, this is carbonyl group conjugated with the double bond system, then double polarization is transmitted through the pi bonds. This conjugation is there, then maybe long chain is possible. So now this is the minus negative charge is generated, and this shift to like this position. Here the plus charge, minus plus bond is forming as the negative charge. Now polarity is produced in the molecule. This effect is called the polarized mesomeric effect. The polarization is also seen in this type of conjugation system. If this lone pair will shift to like this position, this will shift to like this. This will get minus charge. This will get a here this lone pair shifting like this, but actually we can denote like this. We can show this structure like this. Here this is shown. Here is bromine is there. Here is double bonds. Here is double bonds. Here double bonds. This double bond is shift to this position. Here minus charge is generated. Here plus charge is generated, and this plus minus will form a, here is a plus, here is a lone pair. It will form a bonds. After forming a bonds, this is getting plus charge, and in this way we are showing here this lone pair is shifted to this pi bond. Here lone pair is become a pi bonds. In this way this is shown. This is shifted to this position, plus charge generated, and maybe this pi bond electron, 2 electrons shifted to this position, negative charge generated, and this is lone pair is shifted to this positions. In this way similarly this lone pair shifted to this position, this pi bond shifted to this position. Here negative charge is generated, and this become a bond. Here is this is shown. Now this will shift to this position, here bond form. This will shift to this, minus charge generated and minus charge generated, and this way the polarity is produced in the molecule. This type of polarity produced in the conjugation system is called mesomeric effect. Now there are two types of mesomeric effect is there, plus M effect and minus M effect. We will learn one by one, plus M effect and minus M effect.